Hey guys, today's video is over 8.3. This is polar coordinates. So you guys, I have crudely drawn here a polar coordinate system. Don't make fun of this. This is like my third try and this is as good as it gets. So here's our polar coordinate system as opposed to the standard XY plane with the x-axis and the y-axis like we're used to. But we do still have ordered pairs that we use to plot polar coordinates. So I want you to notice, while it kind of looks like you can see an x and a y axis here, that is not the coordinates we use for the polar system. What we use is, notice I've got some special angles mapped out here. I don't have their values, but they're the same ones on the unit circle. So I have all the special angles like the pi over 6s, pi over 4s, pi over 3s. We're going to be sticking with radians today. And then I have these circles, you guys. So we're going to use the circles as one of our coordinates and the angle as the other coordinate. Our ordered pairs are all of the form r theta, so not x and y. So r, you guys, usually we use r for like radius, and that's the case. You guys, your r value is going to tell you how far from the origin you are using these circles with radius r. Theta, of course, is going to be these angles that I have drawn here. So let me give you a couple of examples. I want to plot 3 pi over 4. So r is 2, theta is 3 pi over 4. When you're going to the polar coordinate plane, I would suggest finding your theta place first. So 3 pi over 4, and you can consult your unit circle on this if you need to, because these values aren't always labeled on the polar coordinate system. But 3 pi over 4 is right here. It's the 135-degree mark. It's over in the second quadrant. So I found the angle. You guys, what I know is that because my theta is 3 pi over 4, my point's going to lie along this line somewhere. My r is 2. That tells me from the origin, I'm going out to the second circle here. That's a radius of 2. So if you're on the 3 pi over 4 angle, go out 2 circles with the radius 2. Here is your point. So find the angle, go out that many circles as r tells you to, and there's your point in the plane. So something that can get a little bit complicated is when we have negative values. So let me give you an example. What if I wanted to do negative 2, 3 pi over 4? So I'm looking at 3 pi over 4, it's right here. But you guys, these circles, the origin's 0, r is 0, right? You go positive 1, positive 2, positive 3. What do you think happens if r is negative? You can't have a negative radius, right? So what we do is we go the other direction. So you guys, this direction on our angle 3 pi over 4 is for a positive r value. If you have a negative r value, you have to go the other direction, which means you're going to go into another quadrant. You're going to work this way. So starting with the origin, positive r's go toward the theta in your problem. Negative r's go the opposite direction. So think about, find the straight line that connects 3 pi over 4 to this angle in the fourth quadrant, which is, is actually 7 pi over 4, but we have to be along that line. Your coordinate doesn't say 7 pi over 4, but I know I'm going to be down here because r is negative 2. So I'm on this 3 pi over 4 line, but r being negative 2 means I have to go this direction. So here's r being positive 2, here's r being negative 2. So all the negative does is positive goes towards the theta in your coordinate, negative goes the opposite direction. So we actually ended up with a value at 7 pi over 4. Polar coordinates have a lot of different ways to label their coordinate pairs. This point, for example, the negative 2, 3 pi over 4, it lands right there. But knowing where it is on the plane, could I have labeled this point as positive 2, 7 pi over 4? You guys, in that case, my angle that I started out with would have been this one down here. Because my angle was coming this direction originally, a positive 2 would send r out 2 spaces in the direction of 7 pi over 4. And so what we find is these two coordinate pairs actually map the same exact point. You guys, can you think of a way to rewrite this point with different coordinates? Well, let's think about it. If r instead was negative 2 and our angle was 7 pi over 4, would I get to this point here? Our original angle, 7 pi over 4, would have a positive r that went this way, but a negative r that went back the opposite direction, and we would get right back to this point. So you guys, this negative 2, 7 pi over 4 is actually the same exact point as positive 2, 3 pi over 4. So you guys, you'll have some questions where they'll give you a coordinate pair, and you'll give other ways of finding that same point with different coordinates. So let's plot a couple more things. Let me get another color. I'm going to erase these red coordinate pairs. And we'll put up some purple coordinate pairs and we'll plot those and talk about different ways we could write them. Okay, erase, 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 erase. All right, I've got negative 6 and negative 7 pi over 6. Something terrible has happened to my purple, so I'm going with a different color. Let's try green. I want to make sure it's a color that shows up really well on the black. Okay, so green. Negative 6, negative 7 pi over 6. I need to start with theta. So guys, if your theta is negative, that means starting from the place we always start, from the 0 angle, I have to go clockwise 7 pi over 6. This might be a little hard, especially in radians, because with radians we're used to just counting up the one way. But we can get there, guys. I know it's going to be one of my pi over 6 angles, so I'm going to kind of label a little bit as we go. So going this direction to find negative 7 pi over 6, you guys, this would be negative 1 pi over 6. Keep going this direction. Here's negative 5 pi over 6. And let me erase red coordinates. Go a little bit further, and here's negative 7 pi over 6. So basically, if you didn't follow exactly how I got these values, look at your unit circle and the order that your pi over 6 is going. So positive, pi over 6, then 5, then 7, then 11. Use that same exact order, just go in the other direction. So we have pi, then 5, then 7. If we kept going, this would be negative 11 pi over 6. But we don't need that one. What we're looking for is this one. Here's negative 7 pi over 6. my R is -6. So think about it. Here's the angle in the coordinate pair, which means positive R's would come toward that angle in this direction. R is -6, which means I can't go this way. I have to go the other direction, opposite direction. And I have to go 6. So I have to go 1, 2, 3, 4, 5. Here's -6. All right, so this is -6, -7 pi over 6. Let's talk about other ways we could label this point. Notice that we ended up being at this angle, the -pi over 6. You guys, if you were creating an ordered pair for this very point, and the theta you started with was this one, -pi over 6, what would your R have to be to get here? So starting from here in the direction of your theta, positive 1, 2, 3, 4, 5, 6. So R would be +6. You guys, this coordinate pair is another way to plot this same point. What's another way? What if I asked you to plot this point using only positive angles? Well, you guys, this is -pi over 6, but if you went around the positive angles, this is positive 11 pi over 6. So if you had a coordinate pair using positive 11 pi over 6 and R is +6, would you get to this same exact point? Yeah, you would go to positive 11 pi over 6, you would go toward that angle out 6, and you would still be at this very same point. So you're just going to have to be super careful. If you have a negative angle, make sure you find that angle by starting here and going clockwise to find it. And then pay attention to the positive or negative sign on R. If it's positive, you go, so find your angle first. If R is positive, count out toward that angle. If it's negative, count away or the opposite direction. And you can see by the ones we did, there are a lot of different ways to label the same exact point. Okay, so I'm going to erase this graph because we're going to take a break from plotting. This board is very loud. I apologize. All right, so let's talk about conversions. I'm going to draw the XY coordinate plane because we're converting from polar coordinates to rectangular. So when I say rectangular, I mean the XY coordinates. I'm going to plot a point. Actually, I'll put this line in a minute. I just have a point out here in space. Its coordinates are obviously an X value and a Y value. This is the normal XY rectangular coordinate pair. But let's superimpose our polar plane onto the rectangular plane. So you guys think about your circles being your R values, and we keep going out. I'll get there. I think this one will do it. So you've got all these circles if we were in the polar plane. What do those circles do? They tell you how far from the origin this point is. Notice I went out 1, 2, 3, 4, 5, 6 in this example. But remember, on the rectangular plane, I actually don't have those circles. I don't see them. So I know this value is R. How many circles did I go out? Or what's the radius? Or in other words, what's the distance between the origin and this point? That's what I'm looking for. Okay, so I think we've been here before a lot. Let's make a right triangle out of this. because the last thing I need to find, if I'm going to have polar coordinates, I've found r here, but I need to find theta, right? I need to know the angle. Remember the angles, if they were on here, they would be going out in all directions. I can see the angle that gets me up to this point. It's right here, let's call it theta. But how do I find theta? So on this little right triangle I've created, this long leg is y, right? The short leg is x. I'm just going to use inverse tangent. So let's think about that. The tangent of theta, opposite over adjacent, would be y over x. If you already know y and x, you actually know the tangent, but you don't know theta. So you use inverse tangent. So theta, given a point with x and y coordinates, to find theta, you're going to use the inverse tangent of y over x. That will give you the angle that that point is coming up. How do I find r? You guys look at the triangle. It's a right triangle, right? Think Pythagorean theorem. To find r is the same way you've been finding r before. It's exactly the same. R is the square root of x squared plus y squared. In other words, x squared plus y squared equals r squared. So this tells me that I can go from rectangular coordinates to polar coordinates using these two formulas right here. So let's give it a shot. All right, we're going to leave our formulas. I want to find the polar coordinates that correspond to these rectangular coordinates. So 1, 1. I would always start by making a little sketch of your point and the direction your point is going. When we find the inverse tangent, sometimes we have to work with that to get in the right quadrant. But anyway, so make a little sketch. What am I looking for? I'm looking for a point with a first quadrant angle and positive r. There's other ways you could find it, but you guys, I know I could label this point from an angle down here and a negative r. But this formula that you use, you're going to get a positive r. So what you're going to find is a positive r in the angle that you're going up toward with r. So you just use the formulas, guys. This is x, this is y. Let's find r. R equals the square root of x squared plus y squared. So that's the square root of 1 squared plus 1 squared. R is the square root of 2. And you can just leave it like that. It's exact. Just make sure if you have a root here that you simplify it if you can. But r is the square root of 2. So let's start your polar coordinate pair. R comes first, and it's the square root of 2. All you got to find is theta. So I go over here and I say, okay, if you have x and y, to find theta, you do the inverse tangent of y over x. So theta is the inverse tangent of 1 over 1, which is just the inverse tangent of 1. You guys, if you're using special angles, these are going to be exact. You're going to get an exact answer. You give the answer in whatever it wants. So if it wants radians, for example, I'm going to do this one where I find a radian value. You guys, the tangent is 1 at a certain place. You guys, tangent is 1 at pi over 4, or 45 degrees in the first quadrant, or it's also 1 in the third quadrant at 5 pi over 4. But you guys, I'm looking for a first quadrant angle. So I'm going to say that theta is pi over 4. When I use the inverse tangent with a special angle, I can actually go to my unit circle and find that value. Remember, on your unit circle, you don't have tangents, but you can do the ratios. And honestly, at this point, guys, you should know where tangent equals 1. You should know where it's square root of 3 or square root of 3 over 3. But anyway, I know it's 1 at pi over 4. So my theta, you guys, this angle is coming up at positive pi over 4. So these would be the polar coordinates of this point in the polar plane. So you find r, you find theta, now I have polar coordinates. Let's do another one. Okay, so I want to do the point negative root 3 and positive 1. This is the xy. This is rectangular coordinates here. So x is negative square root of 3, y is positive 1. So let's get started. Let's sketch this. And on the negative square root of 3 part, I know you don't have to be super exact. This is just a sketch. What I'm seeing here is that x is negative, so it's going out this way, and then y is positive. So you end up getting a point in the second quadrant. That picture is just to keep in mind when we're looking for theta. So let's start by finding r though. Finding r when you have x and y should be like second nature to us. We've done this quite a few times for different applications. And this is just another one of them. So you guys, the square root of 3, it's negative. Make sure you have it in parentheses because you're going to square that. So here's x squared plus y squared. Remember that this negative goes away when you square. What happens when you square the square root of 3? Well, you get 3, right? The negative goes away, you just get positive 3 plus 1 squared, which is just 1. And you get r is the square root of 4, and that one turns out great. So you get 2. Okay, cool. So r is 2. We need to find theta. Using this fact, using the inverse tangent, I find that theta is the inverse tangent of 1 over negative root 3. Okay. First of all, I'm going to keep in mind that it's negative. This tangent might not look familiar to you because we don't really use root 3 in the bottom. We rationalize that, right? And if you do rationalize this, I'm looking at tangent equals negative root 3 over 3. So you guys, this and this are the same. This is just a rationalized answer. If you're looking at your unit circle for tangent, you can find this particular ratio using ratios of sine over cosine. Or just remember that tangent is root 3 over 3 at the pi over 6's. So I think, okay, it's a pi over 6. It's negative. So it's in an area where tangent is negative. I need a second quadrant angle. Because of the root 3 over 3, I know it's going to be one of the pi over 6's. And I find it, guys. It's over here at 5 pi over 6. I don't know why I circled that so many times. But you guys, theta is 5 pi over 6. And r is 2. So I get this particular coordinate pair right here, 2, 5 pi over 6. Let me see. I'm going to pause you for a minute. Okay, so these are the two formulas you use to convert xy coordinates like rectangular coordinates, to polar coordinates r theta. Keep in mind that when you do this, you're always going to get a positive r, so the angle that you're looking for is always in the direction of the point that you sketched over here. Now, let's go the other way, because you will have some problems that start in polar coordinates and you have to convert them to rectangular. This has its own set of formulas, and I'm going to derive them for you. They're new, but remember, with the nature of how we're doing things now, you always have formulas to reference. You can really use any reference you want to when you're doing these problems. Okay, so do you remember some basic trig ratios where we used x, y, and r? Remember that cosine theta is x over r and sine theta is y over r. We know this is true. We've used it multiple times. And notice the brilliance of these equations in helping us convert to polar, or to, converting to polar. We have x and y. We have rectangular coordinates in our formulas, and we also have r's and thetas. So you guys, these ratios, the equations that come from these ratios, make it so easy to convert one to the other because it has all the variables necessary. So let's take this one. If cosine theta equals x over r, then what if I multiplied both sides of this equation by r? What would happen? I would get an x by itself because these r's would cancel out. And on the other side, I would have r cosine theta. So I'm going to give you problems in polar coordinates, which means you'll have r and you'll have theta. You can use this little formula to find x. How do you find y? Well, think about it. We're going to do the same thing with the sine theta ratio. You guys, if you multiply both sides by r, these r's cancel out, you'll end up with this. Y equals r sine theta. So if you have r and theta, you can find both x and y to go to xy coordinates. So let me give you an example. I have polar coordinates 2, 5 pi over 6. So this is r, this is theta. You might label that just to keep it straight. Make sure you don't think this is x and y. But I'm going to take r theta and I want to write this as a coordinate pair with x and y. So how do I find x? I use r times cosine theta. So x equals r times cosine theta. So that's 2 times the cosine of pi over 6. Remember, you've got your unit circle handy. But let's talk about the cosine of 5 pi over 6. So it's in the second quadrant. It's a pi over 6. You guys, the cosines there are the root 3 over 2s. In the second quadrant, cosine is negative. So you're going to have your r, and then fill in what is the cosine of 5 pi over 6? Well, it's negative root 3 over 2. Multiply r times theta. Remember, this r is just a whole number, so it's like 2 over 1. Just multiply the fractions. These 2's cancel out. All you're left with is negative square root of 3. Okay, so that is your x value. Let's put it in. Let's find y. Y is r times the sine of theta. So r times the sine of pi over 6. You guys, the sine of the pi over 6's is always 1/2. This is in the second quadrant where sine is still positive, so it's positive 1/2. So I get 2 times positive 1/2. And you guys, what happens is we end up with 1. So you guys, we actually took this as a rectangular coordinate pair and converted it to that. Now, I've shown you that we can go back the other way. I love problems like this where either way you can confirm that these are actually the same point, just using a different coordinate system. Okay, so I want to do one more, converting polar to rectangular. If I can ever get this all erased properly. Okay, so our last example for this video is taking polar coordinates -2, -pi/3. So this is r and theta. And I want to convert this to x, y coordinates. So I need to find x and y. Remember how to do this. X is always r cosine theta. Y is always r sine theta. You guys, with this negative angle, we're going to have to think a little bit. Use your unit circle. Think about going in a clockwise direction. I'm going to sketch it for us a little bit. So you guys, on your unit circle, positive pi/3 is here, right? The 60 degrees. Going the other direction, so going clockwise, go down, here's negative pi/3. You'll notice on your unit circle that that coincides with 5 pi/3. So when you find the cosine of negative pi/3, what you're going to do on your unit circle is actually use the cosine for 5 pi/3. Those are coterminal angles. They're going to have the exact same cosine. Be careful not to use just pi/3. Make sure you call it negative. Okay, so let's find r cosine theta. Well, r is easy. It's -2 because it's right there. The cosine of negative pi/3, or the cosine of 5 pi/3, you guys, that's 1/2, and it is positive because in the fourth quadrant, cosine or your x values are positive. So you have -2 times 1/2, and you get -1 for x. Let's find y. So here's r, -2. Let's find the sine of theta. So we're down here at negative pi/3 or positive 5 pi/3. The sine of the pi/3s is the square root 3/2 value. In the fourth quadrant, sine is negative, so we're looking at negative root 3/2. And we want to multiply these two values together. Notice these two are negative, so it'll turn out positive. These 2's will cancel out. We'll get positive square root of 3. And there's your rectangular coordinates. All right, so that's it for 8.3. I'm going to probably just get started on the next section and get that video out to you as well later today.